Hello students, in this video what we are going to do is we are trying to look at the logarithmic function and how to solve equations using logarithmic functions. So this is the goal of this particular lecture. So let us first get a simple picture. We have already seen how to plot a logarithmic function. Suppose now you have been asked to plot a graph of a function which is log to the base 2 of x, log to the base 2 of x. If you have a graphing calculator, sometimes the old version of graphing calculators do not allow log to the base 2 to be taken, and in that case what you have is either log to the base 10 of x or log to the base e of x, which we have denoted by ln of x. Sorry, this is not e, ln of x. So only these two things are available to you and you can plot these two things. Then can you plot the function log to the base 2 of x? This is what the first exercise that we will do when we try to solve the problems. So fx is log to the base 2 of x. Now using the change of base formula which we derived in the last class, we can easily convert this function into a function with log to the base 10 or log to the base e. For convenience, I will choose log to the base e. So in this case, I can simply convert using my change of base formula. This is ln of x by ln of 2. That simply means what I am doing is I actually need to plot ln of x and scale it appropriately with a constant which is 1 by ln of 2. You can easily evaluate the value of 1 by ln of 2 using any calculator, and this is just multiplied with ln of x. So the graph will more or less have similar features of ln of x, only thing is it is scaled appropriately. You can try your hand in plotting this graph. This is a clear-cut demonstration of the usability of change of base formula. So now you need not have to bother about to what base the function is given. You can simply convert the function into log to the base e or log to the base 10. This I have already told, this is called common logarithm and this is called natural logarithm. That is why the name ln. And once again I reiterate, ln means this is log to the base e of x. I will differ from this notation and I will use this notation for convenience, and it is a standard convention in mathematics to write this as ln. So this is the simplest application of graphing any log to the any base of a function. Okay, let us now come to somewhat tricky application of this, that you have to prove that log to the base 2 of pi plus 1 by log to the base 6 of pi is greater than 2. How will you prove this? Now the key tool while solving all logarithmic equations or inequalities is exponentiation. So we will use that tool over here. So let us start and try to solve this problem. First of all, if you notice in this particular problem, one base is 2, another base is 6. I don't want this. I want everything to the same base. So I will use the same principle that I have used here. That is change of base formula. So let us try to take the left hand side, LHS, which is nothing but 1 over log to the base 2 of pi plus 1 over log to the base 6 of pi. Apply the change of base formula. So log to the base 2 of pi can naturally become log to the natural base e of pi upon log to the natural base e of 2, which essentially gets converted into ln of 2 upon ln of pi. This is again simple application of change of base formula. In a similar manner, I can write this as ln of 6 upon ln of pi. to be very precise, what I did is I substituted log to the base 2 of pi is equal to ln of pi upon ln of 2, and because this thing was in the denominator, because the original fraction was 1 over this, so this is 1 over that, and therefore it will give rise to this particular number. Fine, so this is done, you don't have to worry about this. So now you can see something amazing has happened. The denominator now is actually ln of pi, denominator is same. So I can rewrite this expression as, rewrite this expression as ln of 2 plus ln of 6 upon ln of pi. Wonderful. Now do I know something about the laws of logarithm? This is log of a plus log of b. We have already solved this. This is log of a into b. So I know this is ln of 2 into 6, which is 12, upon ln of pi. Okay. Now this is about LHS. So LHS actually simplified to ln of 12 upon ln of pi. Now the question is whether this thing is greater than 2. I don't know still. Let us say, assume this thing holds true. Then how will you proceed? So let us try to do it in this fashion. I will again consider this particular inequality, and try to see whether this is true or not. ln of 12 upon ln of pi greater than 2. I don't know whether this is true or not, but I know ln of pi is a non-zero number. So I can simply take ln of pi. Okay, is ln of pi positive or negative? It is positive. So I can simply multiply throughout by ln of pi. So ln of 12 greater than 2 times ln of pi. Okay. Now I have one law again to my aid, that is multiplication rule. So log of x raised to a is a times log of x. That rule I will use, and this in fact will become equal to ln of pi squared. Okay. So now I am checking ln of 12 is greater than ln of pi squared or not. This is a question that we are asking again. So all these are questions. We have not yet proved anything. Now both side logs are to the same base. So I can exponentiate this. With E, Euler's number. So if I exponentiate this, then because exponentiation, the operation of exponentiation is nothing but applying exponential function to a particular argument, that is monotone. It is monotonically increasing. So I will have inequalities intact. Therefore e raised to ln of 12 is, I am checking whether this is greater than or equal to e raised to ln of pi squared. Okay, fine. So now you can simply go ahead and try to solve this particular problem. Okay, what is e raised to ln of 12? This particular thing, e raised to ln of 12, e raised to log to the base e of 12. So I already have proved that a raised to log to the base a of x is nothing but x. This we already know using our inverse function definition. Okay, so I will apply this definition over here, and therefore my e raised to ln of 12 will simply convert to 12, which is greater than pi square or not. Is it true or not? We have to check. So now you look at the way we started. We started with some complicated inequality which is given here. Sorry, the inequality, if you include this, some complicated term on the right hand side, some number was there, and now we made it tailored to our understanding, which is whether 12 is greater than or equal to pi square or not. Now how to prove this? Very easy. What is pi basically? It is 3.141 something something, right? This number is strictly greater than 3.15, strictly smaller than 3.15. Okay, so the square of pi, so pi is smaller than this, therefore pi square will also be smaller than 3.15 square, right? And 3.15 square will not exceed 10. You can check for yourself, it will not exceed 10. Therefore this inequality which is under question, it's certainly true, because this pi square will always be less than 10, which is less than 12, and therefore naturally this inequality holds true. So I don't need to put a question mark over here, I don't need to put a question mark over here, and all these inequalities are true, and therefore we have proved that this particular inequality in particular is true. This is the way we will solve a question which is using logarithms. Now you can simply identify what technique we have used. We have used three laws of logarithm. First law of logarithm that we used is change of base. Second law is the multiplication rule. Next, the multiplication rule repeated again here, multiplication rule repeated again, and then the third law, it's not a law, it's actually the definition of inverse function that we have used. Using these three together, we were able to find our answer. Let us try to solve some slightly complicated problem like this. Let us say you are asked to solve log to the base 0.5 of x is equal to log to the base 0.5 of 4. So what do I mean by solve? This is actually solve for x. So you are interested in finding the feasible values of x which will satisfy this equation. Now at the beginning you may be worried about this 0.5 in the denominator, because if you remember, for 0 less than if a is the base, a less than 1, the behavior of log function was somewhat different. Do I really need to worry about it is the first question. Before worrying about anything, let us try to simplify this expression. So what is this expression saying? Let us write this 2 times log to the base 0.5 of x is equal to log to the base 0.5 of 4. Okay, now first thing, if you look at the left hand side, is there any rule that I can apply? Yes, I can apply that power law, power rule. So I can simply convert this into log to the base 0.5 of x square, and then let it be as it is. So it is log to the base 0.5 of 4. Now if you look at this particular expression, and if you look at the denominator, which is 0.5, here also point, not denominator, base. So if you look at this base, you can easily say that the base is common. Therefore the exponentiation trick which we have floated in the last class, that is a raised to log to the base a of x is x. So this trick will work, and therefore I will exponentiate this with respect to 0.5. So I will write 0.5 raised to log to the base 0.5 of x square is equal to 0.5 raised to log to the base 0.5 of 4. What does this mean? This simply means I will get here x square is equal to 4. X square is equal to 4, and now because x square is equal to 4, based on my knowledge about quadratic function, I know x square minus 4 is equal to 0 has two roots, that is x is equal to plus or minus 2. These are the two roots that are available. Now that means I have two solutions to this particular problem, x is equal to minus 2 and x is equal to plus 2. The next question that you should ask is, are these both solutions feasible when I substitute them into this expression? So what is log to the base 0.5 of minus 2? When you look at the logarithmic function, it is defined only on the positive real line. It is not defined on negative real line. So log to the base 0.5 of minus 2 is indeterminate. You cannot determine the value. The function is not defined. It is outside the domain. So this value you can easily chuck off. And therefore your solution, the solution to your problem is x is equal to 2. This is the solution for the logarithmic equation which we are finding. So solve for x, the answer will be x is equal to 2. You can simply substitute it here and check. You put it to 2 square is 4 and log to the base 0.5 of 4 is equal to log to the base 0.5 of 4. What if you put minus 2? This is not valid. Correct? So this way you have to verify once you get the final answer. Let us handle somewhat more difficult problem, which is again going in a similar line, but exponentiation will again help you, but it will reveal some important traits over here. So let us look at this particular problem where the LHS is log to the base 8 of x plus 1 and log to the base 8 of x minus 1. Let us try to simplify. Let us start with LHS. Okay, we want to solve for x, so solving for taking LHS won't help. So let us take the entire thing, that is log to the base 8 of x plus 1 plus log to the base 8 of x minus 1 is equal to 1. It is important to write the equation as it is, because if you write the equation as it is, you will understand the nitty-gritties of this equation. So it is good practice to write once, repeat once whatever is written there. Therefore I am writing this. Do I know any rule, any law of logarithm which will help me to simplify this? Yes, I know multiplication rule. Log of m plus log of n is equal to log of mn. So I will apply that rule and I will get log to the base 8 of x plus 1 into x minus 1 is equal to 1. Okay, now what can I do? What is a way to simplify? Now I want to get rid of a factor of log. So how will I get rid of this log factor? I will exponentiate. So what I will do is I will to the, what is a base? 8. So 8 raised to log to the base 8 of this particular factor. I can rewrite this as x square minus 1, which is easy for me to do, and then this is equal to 8 raised to 1. Remember, if you don't write this step, you may miss out on this. You may write this to be equal to 1. So just write all these things. Then 8 log to the base 8 will vanish, and therefore you will get x square minus 1 is equal to 8. Do I know something like this? I know that x square minus 9 is equal to 0. That means x is equal to plus or minus 3 are the possible solutions. Now is any so in the earlier case, when x is equal to plus or minus 3, where are the solutions? Is there any so for example here in this case minus 2 was eliminated. So here also you need to do a similar check. If you put x is equal to plus 3, if you put x is equal to plus 3, then what will happen? This is 3 plus 1, 4, and minus 3 minus 1. Sorry, plus 3 minus 1, which is 2, and therefore this is 4, and therefore it is a valid expression. So it is in the domain. If you put x is equal to minus 3 and minus 3 plus 1 is minus 2, this is not allowed. What happens here? Minus 3 minus 1 is minus 4, which is also not allowed for putting into log. So minus 3 cannot be in the domain. So only thing that is possible is x is equal to 3 should be there in the domain. Again, when you have solved the equation, it is better to verify. So you write here log to the base 8 of 3 plus 1 which is 4, and 3 minus 1, which is 2, is equal to 1. This is valid. So you have good answer. So x is equal to 3 is the answer to this question. Let us move ahead and solve one question which has different bases. So here is a question which is log to the base 3 of x plus log to the base 4 of x is equal to 4. Now what can you do? Because you cannot use your trick of exponentiation because these bases are different. So what should you do? The first thing is to make the bases equal. How will you make it? One formula is change of base formula. So you apply change of base formula. So as I mentioned, it is better to write the expression once more. Log to the base 3 of x plus log to the base 4 of x is equal to 4. If I want to apply change of base formula, I will simply use this as log to the natural base. So ln of x upon ln of 3 plus ln of x upon ln of 4 is equal to 4. So ln of x is taken in common and therefore I have 1 over ln of 3 plus 1 over ln of 4 is equal to 4. Now you can notice that this particular thing within the square brackets is a number which is non-zero. Therefore I can actually take this number on the other side. So let me simplify this. Ln of x is equal to 4 times. Now when I take this on the other side, it will be a reciprocal of that. So 1 upon ln of 3 plus 1 upon ln of 4. This is what it will be. So can I simplify this? Yes, I can simplify this further, which will give me 4 times so ln of 3 plus ln of 4 will be in the denominator, and in the numerator it will give me ln of 3 into ln of 4. Okay, fine. Then I need to do something which is, let us say, I will do it in this fashion. Ln of 3 into ln of 4 cannot be combined into anything. They will remain as it is. But what can be done is, this is ln of 3 into ln of 4 upon ln of 12. Correct? 4 into 3. I have used the multiplication rule. Fine. So let all these things remain as it is, and because it is ln, I will exponentiate and I will get x is equal to e raised to 4 times ln of 3 into ln of 4 upon ln of 12. If you want, you can merge this 4 with one of these ln's and write this as ln of 3 raised to 4 or ln of 4 raised to 4, whatever you are comfortable with, but I will leave this as it is. So this is the solution, and it's a perfectly valid solution. This is how you will solve a problem which has different bases. So this is a perfectly valid solution. Let us go ahead and try to solve one more example, which looks somewhat ambiguous. In a sense, you have been given ln of x square is equal to ln of x the whole square. How will you solve this problem? That is the first question. So we need to resolve to some methodology. Let us look at this particular problem and try to simplify the things over here. So here you typically, because this is squared, you typically need some knowledge about quadratic functions in order to solve this problem. Let us try to understand this. So let me write ln of x square is equal to ln of x the whole square. In such a problem, can you figure, the first question is, are the bases common? Yes, the bases are common, so there is no problem with this. Now what is happening is, here the term is ln of x, here the term is ln of x square. Can I get the terms which both are in the form of ln of x? Then I can do something with it, right? So I will simply ask that question, and what comes to my aid is the multiplication rule or the power law. Ln of a raised to k is k times ln of a. So 2 times ln of x is equal to ln of x the whole square. Now comes the real power or the real strength. What is happening? It's 2 times ln of x. Now the argument both are same, so you can treat this as composition of functions. So what is happening is, if you write ln of x is equal to t, you are actually talking about 2t is equal to t squared. So what I am doing is, I am putting ln of x is equal to t. This I am defining. Okay, fine. So this particular thing is fine. So what I will do here, very easy then, it's 2t minus basically 2t minus t square is equal to 0. Take out 1t common, so t into 2 minus t is equal to 0, and therefore either t will be equal to 0 or t will be equal to 2. These are the two possible solutions. Okay, so now, but what is t? According to our substitution, it is ln of x. So that means I am saying ln of x is equal to 0. When is ln of x 0? And ln of x is equal to 2. So when is ln of x equal to 2? Right? So these are the two questions that we have asked. So let's say or. And then in both cases you have a natural log, isn't it? So I can exponentiate this particular function. So e raised to ln of x is equal to e raised to 0. You already know a logarithmic function has a point where it passes through 0, and e raised to 0 is e raised to ln of x will be x itself, e raised to 0 will be 1. In this case, exponentiating will give me e raised to ln of x is equal to e raised to 2. Sorry, by default I wrote, so I will write it as e raised to 2. Fine. So that will give me x is equal to e square or x is equal to 1. This is what the answer is. So in this case, x is equal to 1 is one answer, or x is equal to e square is another answer. It is good to go to the original problem and check whether these conditions are satisfied in the original problem or not. So first let us check x is equal to 1. So if x is equal to 1, ln of 1 is equal to ln of 1 square. What is ln of 1? You know the answer. Log of 1 is 0, and ln, so 0 square is 0. Okay, and then if you put x is equal to e square, then ln of e raised to 4, okay, that is 4, and ln of x, that is ln of e square is 2, and 2 square is also 4. So we have verified that both these are valid answers. So what I have said just now is ln of 1 square is 1, so it is 0. X square 1 square is 1, so ln of x square is 0. Similarly, ln of 1 is 0, so 0 square is 0. So the first x is equal to 1 is the solution. In a similar manner, you substitute x is equal to e square and you can plot. Now, it is good thing if you can use a calculator, graphing calculator like Desmos, and plot these two curves and see how where they are intersecting. We have actually given the points of intersection of these two curves. These are the points of intersection of these two curves. You can verify for yourself, and I will see you in the next class. Thank you.